Okie dokie folkies, it's wibbly wobbly idiot vision time again, and this video will probably be a bit wibbly wobbly because there's going to be some handheld stuff going on. Now then, we're doing a bit more work on the mill rather than actually working with the mill, which you can see it has been a bit. We're going to be looking at redoing its power source. Currently it's running off of a rotary phase converter which produces 220 volt 3-phase power, but the motor in the mill is a 380 volt unit. It's a 380 volt 2-speed unit. Now it's a Dahlander motor. Now I've been doing stuff based off of 220 volts, mainly because the Shorblin, the lathe, has a Dahlander 220 volt motor, and at the time when I got the lathe, what are they called? VFDs were very expensive, especially ones that could handle the kind of power that the lathe needs, and especially ones that could deal with multiple motors at once. I just didn't have that kind of money to throw around, but what I did have was a 4 horsepower 3-phase motor, a bunch of recovered capacitors, and some various bits of electrotech. And so I made myself a 3-phase converter. It's not perfect, but it works, and it's enough to drive the lathe, and it's enough to drive the pillar drill, and it's enough to drive the grinder and anything else that happens to be 3-phase that I can set to 220 volts. The mill I cannot set to 220 volts. The mill has a 380 volt only motor, and although it will run with a 220 volt motor, it won't start up in high speed. It won't. It's not good for it, basically. So I did the sensible thing, and I ordered €100 worth of Inflixin, which is a Chinese brand VFD. This is a 9600 model. It was not the one that I was expecting to get. I was expecting to get a 9100, and I was happily surprised. Which takes in 220 volts and throws out 380 volts. And here it is. If I can get it there. There you go. It's very small. It's extremely small, in fact. I have a big industrial 2.2 kilowatt unit. This is a 2.2 kilowatt unit. A big industrial 2.2 kilowatt unit which runs 380 to 380, and it's about 10 times as big. Go figure. Still, it happily fires up the mill, and as a bonus it will actually put out 220 volt 3-phase as well. So this is what is going to be running the mill, and it may well end up being what ends up running the lathe and my grinder and everything else. So, wibbly diagram time. How are we going to deal with this then? At the moment what we've got is the VFD, or a source of voltage, source of current running down L1, L2, L3, the three phases, running to a switch of some description, at the moment a rotary switch, which controls which way the motor turns, whether it goes fast, whether it goes slow. If you were dealing with a completely manual system, within here you probably have a reverser as well, which will switch over 2 of the phases so that the motor runs in the other direction. I haven't got that for the moment. Don't really need to. If I need to run the mill backwards, I rewire the plug. Simple as that. Now, once we bring the VFD into the situation, this is rather naughty. Because if this switch, whether it's a contactor or a rotary contactor or whatever, if that gets switched while this is running, big no-no, VFD makes smoke, or risks making quite a lot of smoke. It's they don't like that. Now, if this was just a standard voltage source, again, we could have a standard switch off of a 24 volt or 280, depending on what the voltage of the contactor is. The contactor's bobbin, it's relay circuitry is. So 24 volts typically. You could switch that. This would switch the contactor, and your motor changes speed. like I said, we can't do that for the moment. So the trivial way that you might want to do it would be to say, right, okay, we take that off the VFD, and we take a T off of that to the motor select, so that the VFD knows to reconfigure itself for running the motor at a different speed. So you've always got the VFD configured the same way that the switch has got all this stuff running, and you're protecting your motor through the VFD. But you're still not protecting the VFD from the motor, which is what we really want to do. So what we need to do is we need to inhibit and hold this in terms of what's being fed back into the VFD and what's happening down here until such a point that the VFD is ready. Right, so this here is how it all works. What we're going to do is we're going to add a second set of relays, which will go blurry, obviously, because that's what you do. We're going to add a dual relay, and we're going to control that with the signal coming from the VFD. Now the VFD has three outputs. They're called TA, TB, TC. These are a relay output which is normally used for feeding current through to indicator lights or alarms or whatever. Now we can make this activate on the VFD running. So it's got a common connection, and then it's got a normally open connection and a normally closed connection. And what we're going to do is we're going to connect our switch, our rotary switch, to our normal switch for the speed, to 24 volts on one side, and we're going to run that through into the common connector of that relay connection. Now when the VFD is not running, the normally closed connection will be connected to common. It will feed down here, it will come in, and it will energize this relay. It will energize the relay. The 24 volts that we've got, the positive connection that we've got coming on through here, will come through this set of connections and go off to our command, which will feed back into the VFD to tell it what motor we're supposed to be driving, and run off to the contactors to drive the contactors. So when we turn this switch off, we've got 0 volts here, which means that we've got 0 volts on here. The relay is not energized, and things go on as normal. Now when the VFD is running, this connection is no longer made. Instead, TB is connected, the normally open connection. Now the normally open connection runs through one of the sets of contacts of the relay. So when this is activated and the VFD is not running, the relay is activated, we have 24 volts fed through to TB, to the normally open connection of the VFD's relay connection. And then when we start the VFD running in that state, that 24 volts gets connected to TA, which drives the relay, which keeps things open. And we can do what we like with this switch. It's no longer connected, it doesn't matter. When the VFD stops running, then this switch takes over again. If this switch is open, then we've got 0 volts here, the relay is not activated, and there is not 24 volts, there's 0 volts on TB at the same time. When the VFD starts running, 0 volts on TB, on the normally open connection. So the relay is not activated, and we stay as we are. Again, given that the VFD is running, switch 1 is completely disconnected. We can do what the hell we like with it. It won't come back into action until the VFD stops. And then we have a capacitor across the coil of the relay, which stops the relay from glitching out when the power goes off. So that is what I have set up here. I have a 24 volt supply. Okay, come on, focus. Fuck it. There we go. That's more like it. We have an industrial relay, which has 2 sets of contacts. If we can focus in on that, I don't know whether we can. Let's try. Come on, focusy, focusy, focus. Yeah, we can just about see it, I think. Yeah, we can see it there. So yeah, we've got two sets of contacts. I'm only using one at the moment because it's just a proof of concept. there's a capacitor running across the coil of the relay, and we're running into the 3 relay connections of the VFD. Here we have our industrial 22mm switch. Right, relay is now powered up. I've got the frequency set to 0 because we've got nothing connected to it. The relay is currently inactive. If we turn the switch on, relay is active. If we turn the switch off, you can hear the relay click out. There's a little bit of time because it's got a fairly big capacitor set on it. So, with the relay off, we can start the VFD running. And now, if we turn the switch, nothing happens to the relay. If we stop the VFD, the VFD is now in stop state. We go back to being able to switch the relay backwards and forwards using our switch. If we now leave the relay turned on and run the VFD, the relay stays activated. Switch makes no difference until, let's turn that off, until we stop the relay, stop the VFD. And the relay stops at the same time because the switch has taken priority. Simple.